Okay, today we're going to talk about Hess's law. Because enthalpy or energy is a state function, meaning it doesn't matter how we get to the end from the beginning, we can use Hess's law to figure out delta H, so our change in enthalpy. So here's another way to find your change in enthalpy. So energy depends on the states of the reactants, their initial states, and their final states. It doesn't matter how they got from initial to final, as long as they did that. The intermediate steps end up being canceled out. So energy change, so enthalpy, remember enthalpy is kilojoules per mole, so that's important. It's the same regardless of the steps that the reaction takes. So our total change in enthalpy of the reaction is the sum of the energy changes in the steps leading to the overall reaction. So that is Hess's law. So we are going to be applying that. So while applying Hess's law, the goal is to achieve the final equation. So if we have a reaction, for example, H2 plus Cl2 yields to HCl, this may not actually happen in just one step. There might be a few intermediate steps that get canceled out. And so Hess's law takes a look at that. We might have to manipulate the other fundamental steps. We might have to reverse the reaction. In that case, you change the sign of delta H. If it was originally negative and you reverse the reaction, then it's going to become positive. Or the opposite, if it was positive, it'll become negative. We also may have to multiply the individual steps by coefficients to make sure things cancel out, and in that case you do have to multiply your energy as well. So let's do 2 examples. All right, example 1, here is the reaction we want. So carbon plus hydrogen gas gives you C2H4 gas. But we're not going to just look at this one reaction. We're going to look at these 1, 2, 3 reactions that make it up. The first step is to write out the steps and make sure that the intermediate products and compounds are canceled out to just leave you with your reaction that you want. So we have 2 carbon dioxide plus 2 H2O. All right, so that's step 1. From step 1, what do we want to keep? Well, we don't have carbon dioxide in the final reaction, and we don't have water. We do have C2H4, but we don't have oxygen. So we need to make sure that the other reactions end up canceling out our intermediate compounds. So for example, we want carbon dioxide canceled out. Well, our second reaction has carbon dioxide as a product. So that is good because if carbon dioxide is needed in a reaction and it's also created in the reaction, it's going to end up canceling out. But take a look at this. In this reaction, we've got 2 carbon dioxides. Here we only have 1. So this is what I mean by you're going to have to multiply. So this whole intermediate step must be multiplied by 2. So we're going to change the coefficients. Still keeps the same ratio, but we now have enough carbon dioxides to cancel each other out. Also, since we want oxygen canceled out, oxygen is a product over here, so it must be a reactant on the other steps, which it is. So we're going to keep these reactions in the same direction. We actually do not need to reverse them. All right, so in this case, we've got 2 H2O here as a reactant, 2 H2O as a product. That cancels out. We've got 2 CO2, 2 CO2, also cancels out. Notice that on our reactant side, we have 2 plus 1 O2. That equals 3. Well, here on our product side, we've got 3. When it's over, what is left? The things that we want in our final reaction. 2C plus 2H2 gives you C2H4. All right, so now that we know this, we can take these numbers to get our delta H. Remember that we took this reaction and multiplied it by 2. So we're going to have to take that energy and also multiply it by 2. So we are just going to add up the kilojoules for each of the individual steps. Notice that I multiplied the second step by 2 because we had to change that coefficient. And when you add that all up, you should get 338 kilojoules. So that is our delta H for the reaction. So that is another way to find delta H, by taking the intermediate steps of a reaction, looking at how they cancel each other, and using their delta H's. So let's do one more example, and then that's it. So example number 2. Again, we have our reaction. 5 carbons, 6 H2 gives us another hydrocarbon gas. So this time, here are our 1, 2, 3 intermediate steps. I want you to notice that in this intermediate step, we only have 1 carbon, but in our final one, we have 5. That should be a clue to you that you are going to be multiplying this intermediate step by 5. You are changing the coefficient to 5. So we're going to start with that. All right. Then, our second step, we have hydrogen gas plus oxygen gas gives you water. Well, let's make sure that we're going to keep it in the same direction, or if we have to flip it. So let's take a look. So we want hydrogen gas as a reactant, so that tells us that we do want to keep this in the same orientation. And notice again, in our final reaction, what is the coefficient for hydrogen? 6, but here it's only 2. So that's your clue that you're going to have to multiply everything by 3. So this becomes 6H2 plus, whoops, sorry about that, 3O2 gives you 6H2O. All right. Now our last step. Well, C5H12, do we want that as a reactant or a product? Look at here, we want it as a product. So that's telling us we are reversing this reaction. We have to flip this. So when you have to flip a reaction, remember the sign for delta H has to change. So we are now going to make this a positive number. All right, and let's take a look at the coefficients. They're pretty good, so we can leave them. All we have to do is reverse our reaction. All right, let's take a look. Do our intermediate steps cancel out? Well, we want carbon, so that's good. It doesn't cancel out. We do want to cancel out oxygen. Notice that we have 5 in this one and 3 here. What's 5 plus 3? 8. And on the product side, we also have 8, so that's good. We do not want carbon dioxide. We've got 5 on the products, 5 on reactants. That cancels. We also don't want water. 6 products, 6 reactants. It cancels. And we are left with what we want. So we set up our intermediate reactions correctly. Now we get to add up the delta H's. Remember, we took the first one and multiplied it by 5, so we need to also multiply the delta H by 5. And the second one, we multiplied it by 3. So we have to take our delta H and multiply it by 3. And the last one, we flipped. So as I said before, we're now going to make that a positive number, not negative. All right, so you add these 3 numbers up, you should get negative 147, oops, 145. Just a second moment. 145.7 kilojoules. Right, that's it. Thank you. Bye.